I technically
Okay.
have to.
So, what a terrible attitude. You get to learn math. So, one of the things we talked about back when we learned negative exponents was how you do not ever write your final answer with a negative exponent in it. There is a similar rule that mathematicians follow that has to do with square roots, which is that you never write an answer with a square root in the denominator. You never leave a square root in the denominator. So if I was to work out a problem and my answer looked like this, 2 over the square root of 3, I would still have some work to do simplifying this a little bit so that the denominator did not have a square root. I'm going to also show you not only how to fix that, but also how to get a square root out of the numerator. The reason I'm going to show you how to get it out of the numerator is because sometimes that's useful to us to make the problem a little easier getting to an answer. But when you're writing your final answer, we want no square roots in the denominator, and that is called rationalizing the denominator. Rationalizing the denominator is the name of the thing you're going to do to get the square root out of the denominator, or very briefly, I'll show you how to do it out of the numerator. So how do I get rid of a square root anywhere? Like if I have a square root and I want to get rid of it, what can I do? Well, one of the things I can do is just erase the little check mark symbol. Unfortunately, that is not a legal mathematical thing for us to do, so we need a different technique. One of the ways, the best way to get rid of a square root is to multiply it by itself. If I have the square root of 3 and I multiplied it by the square root of 3, what would the answer be?
Square root of 9.
Square root of 9, which is
3.
3. So by the simple act of multiplying a square root by itself, the square root disappears.
But what do you have to do at the bottom?
Exactly. I'm not allowed to just multiply the denominator by the square root of 3 just because it makes my life easier. If I do it on the bottom, I have to also do it on the top. So the 2 is also going to get multiplied by the square root of 3. Now the effect here is that on the top, I will end up with a square root, and on the bottom I won't, and that's fine because I've done the thing that I wanted to do, which was get the square root out of the denominator. At this stage, when you're rationalizing the denominator, we do not care how messed up the numerator looks, we just care about the denominator not having square roots. We're very anti-roots in the denominator. And this is true no matter what your denominator looks like. For example, if I were to give you one that had a variable in the denominator, like that.
Wow.
I really do not want that square root in the denominator. I'm fine with the square root in the numerator. In fact, I'm really fine with this square root in the numerator because the square root of 25 is 5. So I'm really okay with that. I could also do some work with this, couldn't I? The square root of 4x is the square root of 4 times the square root of x, which is 2 root x. So before I even do any math, just by doing a little cleanup, on the top I get 3 times 5, and on the bottom I get 2 root x. I still haven't solved my problem of getting the square root out of the denominator, but I was able to simplify a little bit, at least smaller numbers. That's kind of nice. I've got square root x in the denominator though, and I need to get rid of it. Now the 2 is fine. I'm fine with there being a 2 in the denominator. I just don't want the square root x in the denominator. So when I multiply, I'm not going to multiply by 2 root x. I'm just going to multiply by the square root. I'm just going to multiply by the square root of x, which is going to give me, on the bottom, 2x. Square root of x times square root of x is x. Square root times itself just removes the square root. So that's going to give me 2x in the denominator. I have to do the same thing in the numerator, times the square root of x. So that will give me 15 root x. The numerator is gross, but I don't care. My goal was to simplify the denominator. Mission accomplished. You can even do this I say can, you even have to do this when it's not a square root. Cubed root of, let's do a half. So I think the first thing I'm going to do is to separate the numerator and denominator. We're going to do cubed root of 1 over cubed root of 2. And that works out really nicely because the cubed root of 1 is 1. So I'm going to end up with 1 over the cubed root of 2. So it looks a little nicer, still not rationalized, but nicer. Now your temptation might be, I should multiply this by the cubed root of 2, right? We just multiply the root by itself. But let's stop and think about whether this is going to be a smart thing for us to do, to multiply by the cubed root of 2. If I do the cubed root of 2 times the cubed root of 2, what's that going to give me? The cubed root of 4, and the cubed root of 4 doesn't go away. The cubed root of 4 is not a nice number. The cubed root of 4 is something gross. I don't actually want 2 times 2 inside the cubed root. I want 2 times 2 times 2. I want 3 2's because it is a cubed root. Does that make sense? I want 2 times 2 times 2 for a cubed root. So I'm not going to multiply by the cubed root of 2. I'm going to multiply by the cubed root of 2 squared, or the cubed root of 4. Now, why is that good for me? Well, because now I'll have 2 times 4, which is 8, and the cubed root of 8 is a nice number. What's the cubed root of 8? 2. So on the bottom, I've got 2.
And you have to do it on the top.
I got to do it on the top, right? 1 times the cubed root of 2 squared. 1 times anything is itself, so on the top I have the cubed root of 2 squared, or I can just write cubed root of 4. That is very basic rationalizing of the denominator. I am, of course, going to try to wreck your life as we go on. Those are the basics. The basics is you multiply the root by itself, being careful if it's like a cubed root or a fourth root or a fifth root that you multiply by something that's going to get rid of the root. Make sense? Vaguely? It sort of makes sense? Eh? Alright, I'll take it. It's close enough. Let's do square root of 3x over 5. What do you think we should do first?
Separate.
I think separated is a good idea. I like that plan. Really, one of the big reasons we separate them is because if the numerator looks like trash, we don't care. By separating them, we can focus just on what the important thing is, which is that god-awful denominator. Once you get them separated, it seems kind of obvious what you got to multiply by.
5y.
Be more specific.
Square root of 5y.
Yeah, square root of 5y.
25y.
That's the square root of 25y squared, which is 5y. Any root times itself, the root just goes away, right? Any square root times itself, the root goes away. I gotta go on the top also. What is 3x multiplied by 5y?
15xy.
There it is, and it's inside the square root, 15xy. Now if I could simplify the square root of 15xy, I would, but I can't, so I'm not gonna. That doesn't seem too bad. Honestly, if it's a square root, they're really not bad. Square roots are not ugly. We don't mind square roots. You want to see one that we do mind? We really don't like fourth roots. Fourth roots are really pretty uncomfortable. y to the fifth.
Thank you.
Not nice to make fun of people's handwriting.
Alright.
Oh, man. I'm not happy about this one at all.
Maybe 9y.
So what do you think?
9 times 9 definitely is the square root.
Oh, I like what you're doing. What she's looking at is the 81. She's like, is there a fourth
I was
root?
going 9y to the fifth.
Let's leave the numerator alone. Let's focus just on this denominator.
Okay.
Fourth root of 81 times the fourth root of y to the fifth. Is there a fourth root of 81? Is that just a number? Is there a number
No,
raised
it's
to the
3
fourth power?
times 3 times 3 times 3.
Yeah, the fourth root of 81 is 3. What's the fourth root of y to the fifth?
Mine's infinite.
Don't you multiply the 4 times the 5?
No.
Oh, I
It's
think
just
they're not.
fourth root.
We did this last week. You're hurting my feelings.
No, it was not last week. We had spring break.
Oh, sorry, 2 weeks ago.
Yeah. We
Y to the
slept in
fifth is y to the fourth times y. So this is the fourth root of y to the fourth times the fourth root of y. What's the fourth root of y to the fourth?
What?
Y to the
Y.
fifth. Oh, y? Oh, y.
Times the fourth root of y.
Gosh.
So this denominator, this is a 4 by the way, before you start making fun of my handwriting. This denominator can be mostly simplified. I come back up here, I'm leaving the top alone for now, fourth root of x, but on the bottom, we just simplified this into 3y, fourth root of y. Actually, we're able to simplify that a little bit. So on the bottom, the 3y is fine. The part that bothers me is the fourth root of y. What do we need to multiply the fourth root of y by in order to get rid of the fourth root? Again, your instinct may be, let's multiply by the fourth root of y. That's going to be a problem for me though, because that'll be the fourth root of y squared, which does not clean up nicely. You already know though what that needs to be. It needs to be the fourth root of y to the fourth, because when we had the fourth root of y to the fourth, that canceled out and left us with just y. That's what we want. I want the fourth root of y to the fourth. So what do I need to multiply y by to get y to the fourth?
4.
I need it to be 4. What do I need to how many more y's do I need?
3 more.
I need 3 more. Oops. The fourth root of y times the fourth root of y cubed is going to be the fourth root of y to the fourth, which is what I want. Fourth root of y to the fourth is just y. We figured that out a minute ago. Fourth root of y to the fourth gave us just y. So on the bottom, I'm going to have 3y, fourth root of y to the fourth. And you actually simplified that for me the rest of the way. I'm going to do that
Y
here.
squared.
Yep, it can be 3y squared. We're going to do that here in just a minute. If
So,
I multiply it on the bottom, I got to do it on the top also. I had fourth root of x, and now I'm multiplying by fourth root of y to the third. So it's going to be fourth root of,
XY cubed.
there we go. And then you told me that this is, right here is just y, right? Which means I can clean up my final answer. Numerator will be this way. Denominator will be 3y times y. Or 3y squared. Woohoo! What an exciting time to be alive. Yeah? So far so good?
Sure.
Well, let me go ahead and show you the hardest ones. These are the worst they get. I promise. The worst they get is when you have something in the denominator with multiple terms. something like that. That's the worst they get.
Oh, not all of those.
Now here's the reason why these are ugly. Because when you look at the denominator and you see that square root of 5, your thought is probably, I should multiply by the square root of 5, right? Which is a great thought. Here's the problem. Since there is a plus sign on the bottom, if I multiply by the square root of 5, both of those things will get multiplied by the square root of 5. This will get multiplied by square root of 5, which is good, because square root of 5 times square root of 5, no more square root. But this will also be multiplied by the square root of 5, which will give me 2 root 5, and I will still have a square root in the denominator, which is literally the only thing I'm trying to avoid, square root in the denominator. So what do I multiply by? Well, I'm so glad you asked, no one. The thing you multiply by is called the conjugate. Conjugate is what I multiply by. Okay. Here's how the conjugate works. To do the conjugate, you multiply the denominator by itself. I have 3 root 5 plus 2. I'm going to multiply by that with one tiny little change, which is instead of a plus, I'm going to do a minus. That is the conjugate. The conjugate is exactly the same thing, only I switch the signs in between them from a plus to a minus. Okay? Now, how in the world is multiplying by that going to solve my problem? If multiplying by the square root of 5 didn't do it, how is multiplying by this horrific thing going to do it? Again, that is an excellent question that no one asked me. How do I multiply those two things together?
Distributive.
The distributive property. Let's just take these two things. Let's come down here at the bottom and let's sort this out. All right. So let's go ahead and do the distributive property. Doesn't seem too bad. 3 root 5 times 3 root 5. Well, I've got 3 times 3, which is 9. And the square root of 5 times the square root of 5 is square root of 25, or 5. So I got 9 times 5. You could write 45 if you wanted to. We're going to do that in a minute. Okay, let's keep going. Then we'll distribute 3 root 5 times minus 2.
Negative 6 root 5.
There we go. Great. Great. Okay. Then 2 times 3 root 5 gives me positive 6 root 5. And then the last part is easiest. 2 times negative 2 gives me negative 4. Okay. So how did multiplying by the conjugate help us in any way?
Cancel
Well,
out the 2.
check this out. Minus 6 root 5 plus 6 root 5 is nothing, and I'm left with only whole numbers. No square roots. We said just a minute ago that this was 45.
Minus 4.
45 minus 4 is,
41.
so on the bottom I have 41. Sweet. What do I have on the top? Well, I'll multiply the bottom by 3 root 5 minus 2. I gotta multiply the top by 3 root 5 minus 2. And that's a pretty simple distributive property. 5 times 3 root 5 is
15.
15 root 5. And then 5 times negative 2 is minus 10. So on the top, 15 root 5 minus 10. On the bottom, 41. And that's how you do it. word conjugate, but theirs is conjugate. It's totally different. They stole it from us, probably. So that one, the denominator had one square root in it. How is it different when the denominator's got two square roots in it? The answer is not much. It's not much different. All right. What do you got?
You can separate the numerator, the 6 into 4 and 2? Or 4?
No, you're thinking plus.
Oh, okay.
The square root of 6, square root of 5, square root of 3, none of that can be simplified, I'm sorry to say. However, it doesn't mean we're hopeless. I could still multiply by the conjugate on the bottom to at least get rid of the square roots. What would the conjugate of root 5 minus root 3 be?
Plus.
Root 5 plus root 3. I know multiplying by the conjugate is going to get rid of all of the square roots, but it is going to require me to do a little bit of math. So let's come down here and multiply it out using the distributive property. All right, here we go. Root 5 times root 5 is?
15. Or
Why,
25.
why,
25.
why do you hurt me? Square root of 25, which is 5. Root 5 times root 3 is
15.
root 15.
Minus
Okay.
root 15.
Then, negative root 3 times root 5 is negative root 15. So that's nice. And then finally, negative root 3 times positive root 3 is
3.
minus 3.
Minus
And you can already see the good news. Positive root 15 and negative root 15 is gone. And I'm left with 5 minus 3, which is 2. So the denominator up here is 2. Unfortunately, really unfortunately, I have to do the same thing with the numerator, and that one's not going to work out quite as nicely because it's not a conjugate. Which means the square roots are not going to go away. That's okay. I don't really care if the numerator looks like trash, but it does mean that my numerator is going to be kind of gross when I multiply it out. So let's come down, find a blank space here, and do the numerator. I got a blank space, baby, and I'll multiply the numerator. Okay. This looks real gross. I think somebody besides me should do it. I'll just take a little break.
square root of 30
Thank you.
plus square root of 18
Good.
plus 2 with the square root of 5. And then plus 2 to the square root of 3.
Reach. That was good multiplication. I'm about to have a religious experience because of how good that multiplication was. So before we wrap it up and call it good here, the question is, can we simplify any of this stuff? These seem like they're going to be not simplifiable because 3 and 5 are prime numbers, but 18 and 30 have a shot. Is there a perfect square 30 can be divided by?
We discussed that earlier, you said no.
Yeah, no, there's not. What about 18? Is there a perfect square 18 can be divided by? The answer is yes.
16 and 2.
That's not division, that's addition. You're still doing addition.
Well,
What can
4
18
times,
be
4 times.
divided by? 18 cannot be evenly divided by 4.
9.
9. This is square root of 9 times square root 2, which is 3 root 2. Now 3 root 2 is great. Unfortunately, we still can't combine it. Root 30, root 2, root 5, and root 3 are all different, so I can't combine any of that stuff. So this mess right here, square root 30 plus 3 root 2 plus 2 root 5 plus 2 root 3 is the numerator.
Over 2.
Over 2. Uh-huh. So here's my answer.
Holy cow.
Square root 30 plus 3 root 2 plus 2 root 5 plus 2 root 3 over 2. That's the answer. What could be easier? It's about as easy as falling down an elevator shaft. Pretty much no effort required, but the end is not great. You know what? An elevator shaft's a bad analogy. You get the, you understand what I'm saying. You all right about that one?
Mm-hmm.
Sure.
That one, for realsies this time, is about the worst that they get.
That's horrible.
Yeah, I didn't say it was good. I just said they don't get worse.
That's horrible.
That's, yeah, that's about as bad as they get. When you, and the reason that one's bad is not the denominator. The reason that one's bad is the numerator. The numerator is gross. Now, in general, we leave our answers with square roots in the numerator. There are rare, extremely rare instances in which you might want to rationalize the numerator. Usually, when you rationalize the numerator, you rationalize it on your way to simplifying the problem somehow. Like you rationalize the numerator as a little trick to make it easier down the line. I don't think you would ever write your answer without rationalizing the denominator. So we're not going to spend a ton of time on this because it has limited usefulness in math. But I will show you how to do it. And there's really nothing to it that's vastly different from rationalizing the denominator. The techniques are still the same. The only difference is now you're doing it up top instead of down below. As with all these problems, you don't have to do this as your first step, but it's a lot easier if you ask yourself, can I simplify anything? 7's a prime number, so square root of 7 I'm not going to be able to clean up, but square root of 45 maybe. Is there a perfect square that 45 can be divided by? And the answer is yes. 15 is not a perfect square. 5 is also not a perfect square. 9. 45 is the square root of 9 times the square root of 5, which is 3 square root of 5. Cool. Yes, you got it right after I said it out loud. Very good. Math is so easy if you just wait for someone else to say the right answer and you write it down.
Yeah.
No one believes you. So the denominator is nicer, right? It's nicer. My goal here is to rationalize the numerator. You already really know how to do this. What should I multiply the numerator by to rationalize it?
Square root of 7.
Yeah. Square root of 7 times square root of 7 is? 1.
7.
What?
7.
7? Oh my god.
Try to spring break, okay.
Square root of 7 on the bottom also is going to give me.
Oh.
3 is square root of 12.
What?
And
No.
35.
What is happening?
My brain just went.
I don't think just. So, the last thing that I would want to do here is, if I could, reduce this 7/3. 7/3 won't reduce though. So I'm going to leave it like that. My gosh. Very upsetting. higher level algebra responsible for more brain deaths than anything else.
I believe it.
If you go brain dead from doing algebra, should we pull the plug, or how do you want us to handle that? So I want to rationalize the numerator here, and it's the same process as rationalizing a denominator that looks like this. When you have a square root and then a plus or minus, what do you do? Say it again.
Conjunction. Well, that conjugate, whatever you call it.
What do you call it? Conjunction? Conjugate. Conjugate. What's the conjugate of square root of x minus 3?
Plus square root of x plus 3.
There you go. Well, square root of x times square root of x
Square root of x squared.
is square root of x squared, which is x. Now let's see if you can do this without writing. I'm going to do the square root of x times positive 3, and then I'm going to do the square root of x times negative 3. Those are going to go away, right? A positive 3 root x and a negative 3 root x, let's not even write it, because it's just going to cancel out. And then we'll do negative 3 times 3 minus 9. Since I multiplied by square root of x plus 3 on the top, I got to also multiply by square root of x plus 3 on the bottom. So 4 times the square root of x.
4 square root of x.
Good. And then 4 times 3. It almost looks like that top part can factor, and it could if it was x squared. But it's not x squared, it's just plain old x, which means this bad boy is a answer.
Wait, what about 9 and 12?
I could actually factor the bottom, 4 and 12. I could factor out a 4. But it wouldn't help me because I wouldn't be able to reduce anything. Now, if you're asking, can I reduce the 9 over 12? The answer is no, because they're separated by the minus plus sign. When there's a minus plus, it's an all or nothing. Either you cancel the whole top and the whole bottom or nothing at all. You can't do just part of the numerator and part of the denominator. Any questions?
Is that the last one?